Hi there. So here we are, and I'm sure by now you have been able to calculate it, the kinetic, the gravitational potential, and the mechanical energy of the Yeti on this sled. So if you did that correctly, you should have gotten these numbers, and hopefully you did. Again, you're looking first for the zeros. The kinetic energy at the top of the hill is zero because he's not moving there. At the bottom, the potential energy is zero, and you go from there. If you calculate the GPE at the top, is m, so the mass is 100 times 9.8 times 50, you get 49,000 joules. And from there, you can calculate all the rest. Just a little tip also, I'm basically sort of inserting this equation here. So always kinetic energy plus gravitational potential energy is our mechanical energy. And because we don't have friction, we can say this stays the same. So that really makes things easy. So hopefully you've done all that, you got those numbers. And now my next question is, what would be the speed of the sled as it slides down? Okay, because we haven't talked about, we know the height and all that, but can we figure that out? Well, we have our kinetic energy equation, and there is the V in there, but how do we get the V out of that? So let's take a look at how we can do that. So we can rewrite that equation, and since we want to single out the V, we are going to divide both sides by a half m, and we can cross it off on the other side, and then we get this equation. So kinetic energy divided by a half times n, or divided by m, equals V squared. Now, if we put a square root on both sides, we get the following equation. V is Ke divided by 0.5 divided by m. Dividing by a half is the same as multiplying by 2. So this is our final equation. So the velocity is 2 times the kinetic energy divided by m, and then the square root taken all out of that. You can imagine that when the kinetic energy is 0, so 2 times 0 divided by anything is 0, so the square root out of 0 is 0. So the speed at the top is 0. But what will it be for the next one? Well, if we look at the kinetic energy, it's 2 times 9,800 divided by 100. And when you plug in those numbers, you get 196. You take the square root out of that, and that gives you 14 meters per second. So you can write this one down. And what I'd like for you to try is get the velocity of these other two speeds, or I'm sorry, the numbers, the values of the other two speeds as it goes down. And you know what? If you've done that, you can go back to the gizmo and actually check your number. You can certainly take a look at what the velocity is here, because obviously here it's standing still, but if you go back to the gizmo, you can take a look at that. Okay, so add those numbers, calculate it for the other two heights, basically what the velocity is, and also check your work. Should the speed increase or decrease as you go down? It should be increasing, right? Because we get more kinetic energy. Now it can't be like 14,000 meters per second. So you have to, you have here some guideline of what the number should be. All right, good luck.